Hello students, we are solving the IB Math AA HL past papers, and from today we will be starting to solve the IB Math AA HL November 2021 paper 3. Today we will be solving question number 1 of this paper, and we will be solving question number 2, that is the second question and the final question of this paper, in our coming session. And you will be getting the links to all the previously solved questions of all the other papers in form of playlists in my channel. So without any further delay, let us start answering question number 1. It contains many subparts. I have just brought in the first two subparts. The maximum mark is 25. In this question, you will explore some of the properties of special functions f and g and their relationship with the trigonometric functions sine and cosine. Functions f and g are defined as f of z equal to e to the power of z plus e to the power of negative z over 2, and g of z is equal to e to the power of z minus e to the power of negative z over 2, where z belongs to the set of complex numbers. Z is a complex number. Consider t and u such that t and u are real numbers. And subpart A says verify that u equal to f of t satisfies the differential equation d2u dt square equal to u, and it contains 2 marks. Fine. So we start our answer from this point. U equal to f of t. So let us write the expression for u. F of t. F of z equal to e to the power of z plus e to the power of negative z over 2. So f of t will be equal to e to the power of t plus e to the power of negative t over 2. So the first derivative du dt is equal to half is the coefficient. I can write half outside, means then I am putting the parenthesis, and derivative of e to the power of t is e to the power of t, of course with respect to t, and derivative of e to the power of negative t will be negative e to the power of negative t. So this is the first derivative. Now we come to the second derivative, d2u dt square. Half is written first because it is the coefficient. I have made it the coefficient, and then again derivative of e to the power of t with respect to t is e to the power of t, and then derivative of e to the power of negative t with respect to t is negative e to the power of negative t, and there is this minus sign in between, so it will be plus, because minus of minus is plus e to the power of negative t, which can be written as e to the power of t plus e to the power of negative t over 2. Okay, I'm just rewriting this expression in the form that we had found originally. Okay, and this is nothing but u. Okay, so d2u dt square is equal to u, verified. Coming to subpart B, show that f of t whole square plus g of t whole square equal to f of 2t, and it contains 3 marks. Fine, so subpart B, f of t whole square, f of t was this one. So f of t whole square, okay, let me just first of all write the left hand side of this part. G of t whole square, this should be equal to f of t is e to the power of t plus e to the power of negative t over 2 whole square plus g of z is e to the power of z minus e to the power of negative z over 2. So, g of t will be e to the power of t minus e to the power of negative t over 2 whole square. So, this should be equal to, I can take the 4 as the common denominator. Plus 2 square is 4. So, this is a plus b whole square, simple. So, e to the power of t whole square is e to the power of, or let me first of all write e to the power of t whole square. And then plus 2 times e to the power of t times e to the power of negative t plus e to the power of negative t whole square plus the next part. This is a minus b whole square. So, it is e to the power of t whole square. Then this will be minus e to the power of t times e to the power of, okay, I'm putting the multiplication sign, e to the power of negative t plus e to the power of negative t whole square. Okay. So this is equal to e to the power of t whole square is e to the power of 2t. And this is 2 times e to the power of t times e to the power of negative t. This is plus, and there is this term negative 2 times e to the power of t times e to the power of minus t. So these two will be getting cancelled. And we are having, in fact, e to the power of 2t whole, e to the power of 2t over here and e to the power of 2t over here. So this is 2 times e to the power of 2t. Similarly, we are having e to the power of negative 2t over here and another e to the power of negative 2t over there. So that is plus e to the power of negative 2t. Okay. Over 4. These two can get cancelled and we will be having this expression as e to the power of 2t plus e to the power of negative 2t over 2, which should be equal to f of 2t, because f of c equal to, or f of t was equal to e to the power of t plus e to the power of negative t over 2. So f of 2t will be f of e to the power of 2t plus e to the power of negative 2t over 2, which we are having over here. So this is nothing but f of 2t. Okay, shown. So we move on to the next subpart, that is subpart C. Subpart C. Using e to the power of I u equal to cos u plus I sin u, find expressions in terms of sin u and cos u. For I it is f of iu and I it is g of iu. Okay, so let us start with the CI part. CI, it is f of iu. And f of z equal to e to the power of z plus e to the power of negative z over 2. So, f of iu will be equal to e to the power of iu plus e to the power of negative iu over 2. Okay. And e to the power of iu is this. And if you are confused with this part, I can just write this as e to the power of negative iu can be written as e to the power of I times negative u. Okay, so we will be taking this e to the power of negative iu as e to the power of I times negative u. Okay, so this is equal to cos u, this first one, plus I sin u, and then the second one, which I am taking as e to the power of I and negative u. So this is plus cos negative u plus I sin negative u over 2. Okay. And now I come over here. So this is cos u plus I sin u, and cos of negative theta is cos theta. So cos of negative u is cos u. And sine of negative theta is negative sine theta. So sine of negative u will be negative sine u. So it is negative I sine u over 2. So these two will be getting cancelled and we will be having this as 2 cos u over 2, which is equal to cos u. Okay, so f of iu is equal to cos u. Okay, this is equal to cos u. And we come to the II. It is g of iu, which is equal to g of z equal to e to the power of z minus e to the power of negative z over 2. So g of iu will be e to the power of iu minus e to the power of negative iu over 2. Okay. And for e to the power of iu, I will be writing as cos u plus I sin u. And then there is the minus sign. And for e to the power of negative iu, it was these two terms. Okay. We will be taking these two terms. So, and cos of negative u, we had shown that, or we know that to be equal to cos u. So I can write this as cos u. We have shown this once. So you may, if you don't have enough time, you can leave this step as well. Okay. So cos u, and this will be minus I sin u over 2. And you see cos u and minus cos u, these two will be getting cancelled and we are having I sin u plus I sin u. So this is 2I sin u over 2, which is equal to I sin u. Okay, so this is equal to I sin u, right? We have answered subpart C. Let us move on to subpart D. Hence find and simplify. Hence find, that means we should be using the answers found in subpart C, or prior to that means subparts A and B also if needed. And simplify an expression for f of iu whole square plus g of iu whole square. So Let us write that. F of IU whole square plus G of IU whole square. F of IU is cos U. So cos U whole square, and G of IU is I sin U. So I sin U whole square. This is equal to cos square U, and this is I square sin square U. I square is negative 1. So this is cos square U minus sin square U, which should be equal to cos 2u using the double angle identity. So this is equal to cos 2u. Okay. This is cos 2u. So we have answered subpart D. Let us bring up the next subpart E. Okay. Part E. Show that f of t whole square minus g of t whole square equal to f of iu whole square minus g of iu whole square. And f of iu, let me write it. We had found these expressions in subpart C. So f of iu was equal to cos of u, and g of iu was equal to I sin u. Okay, fine. And let us find what is f of t whole square minus g of t whole square equal to. F of z equal to e to the power of z plus e to the power of negative z over 2. So f of t whole square will be e to the power of, or let me write LHS equal to e to the power of t plus e to the power of negative t whole square over 2 whole square minus e to the power of t. G of z is e to the power of z minus e to the power of negative z over 2. So g of t is e to the power of t minus e to the power of negative t over 2 whole square. Okay. So this should be equal to, the common denominator is 4. 2 square is 4. And e to the power of t whole square, it was e to the power of 2t. I am writing that in one step. I'm not writing e to the power of t whole square, and then in the next step I am writing, I'm not taking the 2 steps rather. So e to the power of 2t plus 2 times e to the power of t times e to the power of negative t, and plus e to the power of negative 2t, and then there is the minus sign in between, e to the power of 2t minus 2 times e to the power of t times e to the power of negative t, and plus e to the power of negative 2t. Okay. So we see e to the power of 2t, and this is negative e to the power of 2t. So these two will be cancelled, and this is e to the power of negative 2t. This one is negative e to the power of negative 2t. So these two will also get cancelled. And this one is 2 times e to the power of t times e to the power of negative t. And what is e to the power of t times e to the power of negative t? It is e to the power of t minus t, which is e to the power of 0, or anything raised to the power of 0 is 1. Okay. If you are having confusion, let me just write this. E to the power of t times e to the power of negative t should be equal to e to the power of t minus t, which is equal to e to the power of 0, which is 1. Okay. So 2 times 1 is 2. And this is negative of negative 2, which is positive 2. So this is in fact 2 plus 2, which is 4. 4 over 4, that is equal to 1. Okay. The left hand side, we are seeing that to be equal to 1. So what is the value of the right hand side? Okay. So f of iu is cos u. Okay, let me just write f of iu whole square is cos u whole square, and minus g of iu is I sin u. So it is I sin u whole square, which is cos square u, and I square is negative 1. So negative of negative 1 is positive 1. So therefore this is plus sin square u, which is equal to 1. Okay. Since both the left hand side and the right hand side are each equal to 1, therefore f of t whole square minus g of t whole square equal to f of iu whole square minus g of iu whole square, shown. Okay. Let us move on to the next subpart, subpart F. The functions cos x and sin x are known as circular functions, as the general point with coordinates cos theta comma sin theta defines points on the unit circle with equation x square plus y square equal to 1. This is the equation of a circle with unit radius and with the center as the origin 0 comma 0. Okay. The functions f of x and g of x are known as hyperbolic functions. These two are functions which are defined in this question. Okay. As the general point with coordinates f of theta comma g of theta defines points on a curve known as a hyperbola with equation x square minus y square equal to 1. This hyperbola has two asymptotes. And the question for subpart F is sketch the graph of x square minus y square equal to 1, stating the coordinates of any axis, intercept, and the equation of each asymptote. And it contains 4 rules. I have drawn these two axes before because just to save some time. And let us go to the calculator. I'll be using the TI Inspired calculator to get the graph of this. And this one is not a function equation because it is a one-to-many relation. Okay. And even this is, we know that 1 to 1 and many to 1. Only these two types of relations are functions. But x square plus 1 y square equal to 1 is a an example of one to many relation, which is not a function, because if we have this type of a circle and these are the two coordinate axes for any point x, you will be having two values of y. This will be one value and this will be the other value. So for one value of x, you are having two values of y, multiple values of y. So it is one to many relations, hence it is not a function. Similarly, the equation x square minus y square equal to 1 is not an equation of a function. Okay, it is the equation of a relation. So we have to sketch the relation equation. So we come to the calculator, add graphs, and you see they are just waiting for us to give the function expression. But this F1 stands for function. But we need a relation expression. So I go to graph entry exist and this, and I select this relation. Okay. X square minus y square equal to 1. Okay. See, this is the shape of a hyperbola. X square minus y square equal to 1. And you see the axis intercepts, they are 1 and negative 1. You don't have any y-axis intercept. You have two x-axis intercepts, and there are two branches, and the two x-axis intercepts are 1 and negative 1. And coming to, they have said that this hyperbola has two asymptotes, and we have to get the equation of each asymptote. Okay. First of all, let us get the asymptotes also. Then we will be just copying. Just by looking at this figure, at this graph, what I feel is that this graph will not be having any vertical asymptote or any horizontal asymptote. It will not be having any horizontal asymptote. That is very absolutely clear. But sometimes students think that there will be a vertical asymptote. The y-axis is the vertical asymptote, but it is not, because you see the two, neither of the two branches are coming closer to the point than the point 1 comma 0. The 1 comma 0 is the maximum, the closest point if you approach the y-axis from the right, and negative 1 comma 0 is the closest point closest to the y-axis if you approach the y-axis from the left. Okay, so the y-axis is not the vertical asymptote. This should be very clear. Don't write y-axis as one of the asymptotes. And there is no vertical asymptote, there is no horizontal asymptote. So we are having only one type of asymptote remaining, that is the oblique asymptote. So this graph should be having two oblique asymptotes. And what can be the oblique asymptotes equations? If you just look at the graph, at least I feel that the oblique asymptotes should be passing through the origin. They will be intersecting themselves at the origin. So let us try y equals x as one of the asymptotes equations. Okay. So menu, again graph entry exit. This time y equals x is the equation of a function. So I select function. If one x equal to x, enter. You see, this is indeed one of the oblique asymptotes. And the other should be, I think, y equals negative x. Let us check. Function negative x. Yeah. So these are the two oblique asymptotes, y equals x and y equals negative x. Okay, fine. So, fine, let us first of all draw the oblique asymptotes. Uh, fine. And the other one. Okay. Hmm. Maybe this way. Okay. So, fine, these are the two oblique asymptotes. And we need the graph. Let us see what is the graph. The graph is between these two and these two. Okay. So and they should be passing through these 2 points. This is the negative one, this is positive one. So they should be passing through these 2 points. Oh, I'm just drawing a rough sketch. Okay, so this is x square minus y square equal to 1. Okay? And the axis intercepts sorry, r 1 comma 0 and negative 1 comma 0. Okay? And the oblique asymptotes are y equals x and y equals negative x. This one is y equals x and this one is y equals negative x. Okay, fine. And this one is 1 comma 0. This is negative 1 comma 0. So we have drawn the graph and we have given the relevant information. So we have completed subpart F. Let us move on to the next subpart, the subpart G. Okay. The hyperbola with equation x square minus y square equal to 1 can be rotated to coincide with the curve defined by x times y equal to k, where k belongs to the set of real numbers. K is a real number. And the question for this subpart G is find the possible values of k. So most probably k will be having more than one value. And the marks for subpart G is 5. Okay, fine. Now we have seen the graph of x square minus y square equal to 1. What will be the shape of the graph for y, x times y equals k? K is a real number. So we have seen the graph of x times y equal to or xy equal to k. If k equal to 1, xy equal to 1, that means y is equal to 1 over x. We have seen the graph of y equals 1 over x. It is somewhat of this type. The, the two asymptotes are the vertical asymptote is the y axis and the horizontal asymptote is the x axis. Okay. Also, we have seen the graph of xy equal to negative 1. Okay, let me just show you. Okay, I'm having the calculator. So let me show you the graphs of xy equal to 1. Let me take a function, okay? 1 over x. I'm taking 1 over x. So this is the graph of y equals 1 over x, similar to this. Rather that this one is similar to that one. And if I graph y equals negative 1 over x, what do I get? Okay. See, it is this way. Okay, that means this way and this way. The second quadrant and fourth quadrant. For xy equal to -1 and for xy equal to +1, it is the first quadrant and the third quadrant. And of course, if it is not equal to 1, but some other real number, it will be the case of a vertical stretch. Let me show you. We are having too many graphs, but even then, let me just show you one more function. Maybe this time, let me take 3 over x. See, it is simply the vertical stretch happening. 3 times 1 over x. K times, or k is over here. Okay, I may take it as r times 1 over f of x, which is 1 over x. Okay, so it is the case of a vertical stretch. So let me just get another one because it is too clumsy over here. So first of all, I draw x square minus y square equal to 1 one more time. Okay, fine. And now let me draw x y equals 1 over x. Okay. So this time it may be a function. It is a function. So 1 over x right. Now they are saying that the graph of this equation can be rotated in which direction they did not specify. It can be clockwise or it can be anti-clockwise with the curve to coincide with the curve defined by xy equal to k. K is a real number. So in our case, in this these two graphs, this f6 of x, I have taken k value as 1. Okay, so it is y equals 1 over x or xy equal to 1. So they are saying that the hyperbola can be rotated in some direction. Rotated whenever we are having the rotation, we actually, you remember in IGCSE, we have learned about the transformation of functions over there. We have learned about the rotation. Whenever we had to describe a rotation, we had to say that what was the degree of rotation, and we had to specify whether it was in the anti-clockwise direction or in the clockwise direction, and also we had to specify the center of rotation. Okay, so over here they did not say the center of rotation, it is the origin. Okay, so now, okay, let me just draw the two asymptotes, the oblique asymptotes. At least let me draw one of them. Okay, so you see, when we are taking the graph y equals 1 over x, that is the reciprocal function graph, the orange colored graph, we are having the two asymptotes as the vertical asymptote as the y-axis and the horizontal asymptote as the x-axis. Yeah. And for the hyperbola, we are having two oblique asymptotes. One is the y equals x, and I did not draw the y equals negative x, but it is there. So for the reciprocal function, we are having the two asymptotes, the vertical one and the horizontal one. And for the hyperbola, also we are having the two asymptotes. the two oblique asymptotes. Okay. So if I try to, because if I take the asymptotes, you see, it becomes easier for us to understand the angle through which it is getting rotated. And the asymptote is passing through the through the origin rather, 0 comma 0. So if I just rotate this asymptote y equals x, it is inclined at an angle of 45 degrees with the x-axis, because y equals x, every point on this line will be having the x and y coordinates the same. Okay, so it is rise equal to run. So tan theta equal to 1. That means theta equal to 45 degrees. Therefore, because did you understand what did I say? Suppose there is a point 1 comma 1 on this line. Let me write it over here. This is the line y equals x. Maybe this is 1 and this is 1. Okay. So there is this point 1 comma 1 on this line, definitely, because it is y equals x. There is 2 comma 2, negative 1 comma 1. I am just taking one of them, 1 comma 1. Okay. So if I just take this right angle triangle, what is the rise? It is equal to 1. And what is the run? It is equal to 1. So this is theta. Therefore, tan theta should be equal to rise over run, which is equal to 1 over 1 or 1. Therefore, theta is equal to 45 degrees or pi by 4, whatever you want, you may write. Okay. So this line y equals x is at an angle of 45 degrees with the x-axis. And of course, this angle is also equal to 45 degrees. Okay. And we are seeing that the hyperbola is having this y equals x as one of the oblique asymptotes. And the reciprocal function graph is having one of the asymptotes as y-axis and another as the x-axis. So in order to make this line y equals x coincide with either the x-axis or the y-axis, this is the x-axis, this is the y-axis, in order to make this line y equals x coincide with either the x-axis or the y-axis, it should get rotated through an angle of 45 degrees. If it is rotated through an angle of 45 degrees in this direction, means in the clockwise direction, it coincides with the x-axis. And there is the other line also. It is not that there is only a single asymptote. There is this line as well, y equals negative x. This is y equals negative x. Okay, if we are rotating these two through an angle of 45 degrees in the clockwise direction, okay, so in the clockwise direction means in this direction. So this line, this y equals negative x, when rotated through an angle of 45 degrees in the clockwise direction, and the center of rotation is of course the origin. This one will be coinciding with the y-axis. It will become the vertical asymptote. And the y equals x line, this one is also getting rotated to an angle of 45 degrees in the clockwise direction. So this one coincides with the x-axis. Clear? So we have come to this conclusion that 45 degrees angle is the angle of rotation. And should we be rotating these two the whole figure, in fact, the whole parabola, the hyperbola graph. But if you consider, I think if you consider the two asymptotes, the angle becomes much more easier to be detected. Okay. So this is the case when we are rotating the two asymptotes, the two oblique asymptotes in the clockwise direction. The y equals negative x line coincides with the y-axis and y equals x line coincides with the x-axis when they are rotated through an angle of 45 degrees in the clockwise direction. What happens when we rotate them in the counterclockwise direction? In this direction. So when we rotate both of them in the counterclockwise direction, this y equals x line, it will be moving in which direction? It will be moving in this direction. So even if this, sorry, it is moving in this direction. Sorry. This I have drawn in the clockwise. Very sorry. Counterclockwise is this. Therefore, the y equals x line is moving in this direction. Hence, the y equals x line is coinciding with y equals x, the y axis. And the y equals negative x line is moving in this direction, in the counterclockwise direction. So, the y equals negative x line is coinciding with the x axis. Therefore, when we are rotating through an angle of 45 degrees in the clockwise direction, the y equals x line is coinciding with the x axis and the y equals negative x line is coinciding with the y axis. And if we are rotating the whole thing through an angle of 45 degrees in the counterclockwise direction, then the y equals x line is coinciding with the y axis and the y equals negative x line is coinciding with the x axis. Okay. So we are seeing how are we having these two asymptotes, the y equals x and the y equals negative x, the two oblique asymptotes, how are they getting changed to one vertical asymptote and one horizontal asymptote when we are rotating the whole thing through an angle of 45 degrees, either clockwise or anti-clockwise. Clear? So we have come to the conclusion that we have to rotate the whole thing through an angle of 45 degrees about the origin. We can rotate it in the clockwise direction or in the anti-clockwise direction. Clear? Fine. So now this is the origin. And this was the, and whatever, because it is containing 5 marks, whatever I am explaining, you have to show these. Okay. It is not that you will not be showing these. And this graph also you should be. So this one is 1 comma 0, this point. We have seen that. Now, and this is negative 1 comma 0. So if I draw a circle, I can definitely draw a circle with the center 0 comma 0, the origin, and the radius as 1 unit. So the circumference will be having one of the points as 1 comma 0, another point as negative 1 comma 0. That is clear. Fine. So every point we have considered only the two asymptotes. So when we are rotating the graph, the hyperbola graph, every point on the hyperbola graph will get rotated through an angle of 45 degrees, either in the clockwise direction or in the anti-clockwise direction about the origin. Okay. So I am just rotating it for the time being in the anti-clockwise direction. You can rotate it in the clockwise direction also, doesn't matter. I'll be rotating in the clockwise direction as well. Okay. But first of all, I am considering the anti-clockwise direction. So this point 1 comma 0, this is the 45-degree angle. And since I am rotating it in the anti-clockwise direction, this point is coming to this point, okay? Because this is the radius, this is 1 unit, even this is 1 unit. So this point has come to this location, this position. This is the 45-degree angle, okay? Or pi by 4. So the coordinates of this point may be P. This point should be cos pi by 4, comma sine pi by 4. Okay, because it is a unit circle, and we know that every point on the unit circle will be having coordinates of the type cos theta comma sine theta, and theta in this case is a positive angle pi by 4, so it will be cos pi by 4 and sine pi by 4. And what is cos pi by 4? It is 1 over root 2. So this is 1 over root 2, and sine pi by 4 is also equal to 1 over root 2. So the 1 comma 0 point goes to 1 over root 2 comma 1 over root 2 point location. Okay, we'll be having coordinates as 1 over root 2 comma 1 over root 2. So if, and the equation is xy equal to k. So if x equal to 1 over root 2, so if when the hyperbola uh, and I'm not writing the explanation of how did I get the theta over theta equal to 45 degrees, but I am again repeating, you have to give this part. Okay, you draw the diagram and explain, or yes, you have to draw the diagram. That will be lessening some of the statements that are required. So hyperbola is rotated through an angle of pi by 4 in the anti-clockwise direction the point 1 comma 0 comes to 1 over root 2 comma 1 over root 2. Okay, therefore xy is equal to 1 over root 2 times 1 over root 2 equal to half equal to k. Clear? So this is one of the values of k. Doesn't matter whether we had taken y equals 1 over x. We can take y equal to 2 over x, 3 over x, whatever it is. You have seen the shape is just like this. Okay, so the vertical and the horizontal asymptotes will be the same. And now we have considered the anti-clockwise rotation. What if we rotate the whole thing in the clockwise direction? Okay, so in the clockwise direction, maybe over here, this may be taken as 45 degrees. Okay, so this one is P1 or P prime, I can write. This is P and this is P prime. And this angle I have rotated this in the clockwise direction. So whenever we rotate something in the revolving ray in the clockwise direction, the angle formed is a negative angle. So this is negative pi over 4. Okay. So when the hyperbola is rotated in the clockwise direction, the angle formed is negative pi over 4. Okay. Therefore, the coordinates of the current location of 1 comma 0 becomes, it will be cos of negative pi by 4. Cos of negative pi by 4 is cos of pi by 4, which is 1 over root 2. And sine of negative pi by 4 is negative sine of pi by 4. So it is negative 1 over root 2. Okay. Therefore, xy equal to 1 over root 2 times negative 1 over root 2 equal to negative half, which is equal to k. Okay. So we have found half equal to k and negative half equal to k. Therefore, possible, I hope you are being able to see, possible values of k is equal to plus minus half. Okay. So this completes our question number 1. And I am Nilanjana Sanyal. I am an online IB Math A, SL and HL level tutor, and I tutor students from both within India and outside India. And currently I am solving the past paper questions, the IB Math A, HL past paper questions. You are seeing these questions solved, and in case you are liking my explanations, please to give these videos some likes, and please to share these videos with your friends so that even them, they can get benefited by viewing these videos. Okay. And please do subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And we meet again very soon in our next session. Thank you for staying with me till the end. In our next session, we will be solving question number 2. So till then, bye.